So today we have array2 has 77. Given an array of integers, we want to return true if the array contains two sevens next to each other, or there are two sevens separated by one element. That is to say that if, of course, in the array, in any given array, if, of course, we encounter a 7, we want to check if the next element is equal to 7. And in the event that it's not, we also want to return true if the next to next element is 7. In other words, if I have two sevens in an array, then I want to return true. And I also want to return true if I have two sevens in an array separated by an element, which is, of course, an interruption to the continuity of the sevens, but only one interruption. So in both cases, I'd want to return true. And if, of course, neither of those conditions are met, I'll certainly return false. I do want to sort of cover two situations here, two solutions, one rather inefficient and one somewhat more efficient. And I want to show you what intuitively one may think and why that may be wrong, and actually how to offset some of those errors we get on the side once we run those wrong test cases. So you could think, well, okay, I'm going to have a for loop. I would need a for loop. I would need a for loop. Int I is equal to 0. I is less than nums.length, and I is plus plus. And so essentially what this would do is it would allow me to iterate through the length of the array and essentially look at each element such that I is less than nums.length. In other words, the length of the array or the total number of indexes in the array is always going to be less than the length itself. And so if I is less than nums.length, then we're not walking off the edge of the array. We're in fact exactly iterating within the confines of the array length. So here within the for loop, we can say, okay, well, so given an array of integers, we want to return true if the array contains two sevens next to each other. So we could say if, okay, well, if nums of I, right, and that is, of course, any given I could be any given value. It could be 1, 2, or 3, or whichever. It could be any value, and that would represent what index we're on. That index would represent an element which resides at that index. So the index is but a reference for the element. So we could say, okay, if nums of I, if any given element is essentially equal to 7, and nums of I plus 1, that is, of course, to say that we want to look at the next element by incrementing the index by 1. Thereby, we are actually looking at the next element in the array because we've incremented our index. And so if nums of I is equal to 7 and nums of I plus 1 is equal to 7, then, of course, we'd want to have, let's say, a Boolean variable, maybe a Boolean variable. Let's say we could call this status. We could set this to true, and we could say, okay, well, if this is the case, then we want to set status equal to true, or actually, by default, we'd want to set it to false. And if, of course, this condition is satisfied, then we'd want to set it to true. But you recognize that this condition only takes into account if one 7 is followed by another 7. In other words, we have another condition here, another scenario which can actually return a true outcome, which is, of course, to say that if both of those 7s are sort of interrupted by a 1 in the middle, or actually any element, then we'd also want to return true. So instead of writing another if statement, why not merge this and say, okay, or if nums of I is equal to 7 and nums of I plus 2 is equal to 7. And I say 2 because when we're doing this, if you think about it, if nums of I is equal to 7, let's say nums of I is equal to 7 here, where the index is 1 and the element, we're on the second element. So if nums of I is equal to 7, I want to check, not only do I want to check well, I don't want to really check the next one, because if this wasn't satisfied, then we're on this one, right? And I want to check if the next to next element is equal to 7. In other words, checking the next to next element would just be, in essence, checking this index plus 2. And so I say, okay, if nums of I is equal to 7 and nums of I plus 2 is equal to 7, then also we'll set the status equal to true. And of course, after it's all said and done, I'll essentially return status and expect to have a favorable outcome. But you'll notice that we get array index out of bounds exception errors across the board. We get a couple right, not many, obviously, but we get this array index out of bounds exception, and that's essentially because, so if you think about it, right, if we had an array of, let's say, 4, of length 4, that is, of course, the number of boxes in memory, and if we had some arbitrary numbers in here, and we had, let's say, a 7, so we come down here and we're looking at, we're essentially looking at we've iterated through, and none of these elements have satisfied this if condition, and so status is always equal to false. But as soon as we're on the last element in the array, it says if nums of I is equal to 7, and nums of I plus 1 is equal to 7. So what it does is it says, okay, if we're on the last element in the array, we're actually at the 3rd index, because inclusively the count for the index starts from 0. So we're on the 3rd index, and now the program is saying, okay, I want to check if the next element in the array is equal to 7. And the next element in the array is referenced by iterating the current index and then adding 1 to it. And so now we're checking this element, which doesn't even exist, nor does this index exist. And then, of course, then we get our array index out of bounds. Similarly, so that's one scenario where we're getting our index out of bounds error. But of course, if we had, let's say, so you'll see that if we wanted to check the next element in the array, then we have to somehow take into account that what if the 7 is the last element in the array. And so what we do is we say, okay, I should be less than nums.length minus 1, because we know eventually we're going to iterate by 1. And if we iterate by 1, we don't really want to iterate for the entire length of the array. We only want to iterate for this length, and then knowing that our program will eventually iterate 1 regardless, we essentially just say, okay, just iterate until here, so that I is less than nums.length. Nums.length is 4. And if I is less than nums.length, then I must be less than 4. In other words, the I resolves to 3, and since I must be less than 4, we iterate for the entire length of the array. However, if we do nums.length minus 1, then we say, okay, we're going to iterate for I should be less than nums.length. Nums.length is 4, minus 1 is 3, so I must be less than 3. In other words, I is simply going to stop iterating when it's less than, it's going to stop iterating here on the last element, or the second to last element. And then knowing that I is going to be incremented by 1 regardless once we're inside the for loop, we essentially take into account that fact, and we say minus 1. And so that's why this works. But you'll see that it works for this particular scenario. And when we run this here, we get a couple more greens, actually a lot more greens, because, well, it works. And so, but you'll notice that what if 7, so it works if it works for a lot of cases, but you'll see that in this case here, we also want to increment by 2 to check if the second element is 7. And what if 7 is, let's say, we're on this element, and then we increment by 2, so I is in fact equal to 7, and then we say I plus 2, check if I plus 2 is equal to 7, and then we go I plus 1, and then I plus 2, I plus 2. That array, or that element referenced by that non-existent index, doesn't even exist, and so we get another index array out of bounds exception error. So the way to sort of, now you can't just do this, right? You can't say nums.length minus 2. You can't say that, and you'll see that we get a lot of falses. And you can't say that because just as we had said that nums.length, just as we had said that I is less than nums.length minus 1, we'll iterate for a complete number of times 1 before the array itself ends. Similarly, if I is less than nums.length minus 2, then it's only going to iterate 2 before, it's going to iterate for all the elements that come before the last 2 elements in the array. And so it becomes problematic, because what if we had 2 7s here? right? You'll see that we had 2 7s here. Well, we're not going to even ever touch those. So it becomes really problematic to do this. So the problem here is we can't do 1. We can do 1 and it would work for one case, and we could do 2 and it would work for the other case. But we can't simultaneously do both because, well, we can't. That's not how the for loop declaration works. So what you could do sort of in this case is you could have another condition. You could say, well, let's not merge them. Let's look at them individually. Say, okay, if I is less than, if nums of I is equal to 7 and nums of I plus 1 is equal to 7, this will only work, but I, that is of course the index, must be less than nums.length minus 1. In other words, I must be less than nums.length minus 1, which is of course to say that we must, the iteration that we're on, the index that we're on, should be less than the length of the array minus 1. Then and only then does it make sense to increment by 1, right? Then and only then is it possible. So if you think about it here, we have, let's see, 3 elements, 0, 1, 2. So if 7 was here, so let me draw some things here. So the length of the array is 3, right? Total number of elements is, indexes is 2. So if in fact I is less than the nums.length, which is 3, minus 1, which is 2, so I is only going to iterate for a total number of 0 to 1 times. And then knowing that inside this for loop, we're going to increment I by 1 regardless, it does that for us, but it doesn't walk off the edge of the array. It stops iterating then. So that's how we take care of that. So if I is less than nums.length minus 1 and nums of I equals 7 and nums of I plus 1 equals 7, then and only then could we do this. Now, this would essentially work for if, let's say, 7 was here, right? Because when we come inside here, I is less than nums.length minus 1, right? The I here is 0, and it's less than the length of the array, which is 3, minus 1, which is 2. So it works for each and every element that which comes before that as well. It's not just for the case that, the second to last element. And we say, okay, we're gonna sort of set the status to true in the event that this exists, in the event that this condition is met. Similarly, we're going to go inside here and we're going to do the same thing for, we're going to say, okay, well, what did we want to do? We wanted to do nums of I, if nums of I is equal to 2, and nums of I plus 2 is equal to, if nums of I is equal to 7, and nums of I plus 2 is equal to 7, then we also want to set the status equal to true. Okay, but again, this poses problems. And this poses problems because we have the array index out of bounds exception errors. And so what we can do is we can say, okay, only do this if I is less than nums.length minus 2. Then and only then can we actually iterate through the length of the array without actually walking off the edge of the array. And so you look back here at our example, and if let's say if this was 7, this was 1, and this was 7, so it says if I is less than nums.length minus 2, nums.length is 3, total number of indexes is 2, nums.length minus 1 is 2, so I must be less than 2. Nums.length minus 2 is in fact 1, and so it says that we're only, so there are a valid number of indexes or elements which follow this particular index, and so we can increment by 2 without actually walking off the edge of the array. And so and so this works. Okay. Now, another way you could have done it without worrying so much about walking off the edge of the array is you could have had 2 for loops. So this for loop will check for this for loop will check for sevens. Okay, this for loop will check for sevens or sevens next to each other. So we have a for loop int I is equal to 0, I is less than nums.length, I plus plus, and then we could have said, okay, well, if of course any given element referenced by its array is equal to 7, and nums of I plus 1, that is of course the next element in the array, is equal to 7, then we can set a variable that we have, let's say Boolean 7 equals false, and we can go ahead and set 7 equal to true in this case. But of course, if nums of I is equal to, well, yeah, so this array is just going to allow us to judge whether or not there is a 7 at the next element. And since we are in fact incrementing by 1, we want to ensure that we're not walking off the edge of the array, and so we do -1 here. And we'll set 7 equal to true. Then we'll have another for loop, which will check for the other case, which is something like 7, a 7 next to a 7, but of course separated by 1. And so we say, okay, int I is equal to 0. I should be less than nums.length -1, and then increment by 1 each time. But of course, we're going to do -2 this time because we actually want to look at the next to next element. So we say, okay, if nums of I is equal to 7, and nums of I plus 2 is essentially equal to 7, then of course we will set a Boolean variable which is keeping track of, let's say this Boolean variable is going to keep track of, I'm going to call this 7,1 to say that it's separated by 1, and 7,1 is equal to false in this case. Or sorry, it's originally equal to false, but we'll set it to true if this condition is satisfied. And by now, we have a pretty good measurement if this is true and this is true. In other words, if 7 and 7, or if either or are true. In other words, if let's see here, if 7 is equal to true or 7,1 is equal to true, either or, then we'll set our overall status for equal to true, or equal to false to begin with. But if either or is true, then our status is equal to true. And we can just then, of course, return our status. And of course, if status is not equal to true, then status is equal to false to begin with. Now, this works, but isn't necessary. You'll think so. So if you look at it here, we don't actually have to have 3 different variables keeping track of this stuff. Let's see here. Maybe we could just have 1 variable, right? Or let's see. If, of course, we have a 7 followed by a 7, we'll return true. And here it will return true as well. And if not, then if either or are not set to true, then we just return false. And we get the same answer. So we've saved ourselves a lot of space in that regard, and it's a little more efficient. So that's another way to do it. Many different methods here, many different methods.